each joint, like shoulder, elbow, and each of those has a XYZ position and a quaternion for orientation. So you get to just pass your skeleton variable in this C++ object-oriented kind of way to another node, and that's going to carry with it all the data that composes where your body pose, essentially. And so that's pretty nice because you're not writing like strings. You're not some long string that has all sorts of components, and then you need to encode it and decode it and figure out if there's any data lost. So then on top of that, the next level of complexity is a service. This is just when something doesn't want to just send information out to the ether. It wants to ask for something and get something back. That's like a separate definition you have to do. You have to define the format of the request and the reply. And then a stack is really just like an organizational unit that is composed of those three. And it usually represents some larger thing, like MIT has its own stack that you just go grab, and so you get all the message definitions and the drivers and everything that they need to run their software. That's why we could just get that demo and run it right away, is because it was in this unit called a stack that had everything we needed. Yeah, and the thing with these packages, I'll talk about a little bit more about this later, but you generally want them to represent some functional unit. So you have to think a little bit about how you want to write your code and implement it. Okay, so what do you see when you start up ROS? Like, what's going on in the background here? Well, there's this master thing that is sort of the coordinator. You don't really interface with it, but you need to start it before anything's going to work. But after that, it just kind of hangs out in the background. And then the nodes are what you really deal with. And these are the executables that you write. And as I said, in C++ or Python. And you really want to do it so that, for example, with the connect, one node is going to be the drivers for the connect device. Another node is going to be an object tracker that takes that data coming in, and it finds the object, and it finds the centroid, and then it publishes in a message out to the rest of the ROS world where that object is. So that would be one node. Another thing you could do is write another node to track a skeleton. That's also taking the connect data. It's fitting skeleton to it, and then it's sending that information out. Now those two nodes are both using the connect data, but you can start them and stop them separately and run them at the same time. So that kind of gives you that modular functionality. And then there's a parameter server, which is kind of like a place where you put all those global variables that you normally have that everybody needs to know about. And you know you're not supposed to do it, but you do it anyway because it's easy. And so this is nice when all the nodes might need to know a few state variables or configuration variables. That's where you keep it. Okay, so I touched a little bit on communication. I mentioned everything communicates with these messages that you can define as packages. And then there's really two ways these messages are passed. Topics, which is essentially, it's sort of decoupled the production and consumption of information. What I mean by that is one node just is streaming data to the world, and it doesn't care what happens with it. It doesn't even know anything about how many people are listening. It's just giving data out. And then there's another side where you subscribe to that topic, and you can consume that data. And multiple people can subscribe to or publish to the same topic. So it's a very open-ended kind of communication.
Real quick, you can also subscribe like in two different ways. Like you could subscribe to a topic and say, every time he sends out a new message, I want to grab that and do something to it.
Yeah.
Or you can subscribe at like a set frequency. So if like our Connect publishes at 30 hertz, we could write a subscriber that subscribed at 100 hertz, and it would be getting the same data over and over, but then we could like use that subscriber to run like a different control that ran at a different frequency, and it just handles all of that process management to make that happen.
Yeah. So the other option is something more like an interrupt, where every time you get a new message on that topic, you take it and do something with it, whether it be store it or otherwise.
So is it fair? I mean, it sounds like a lot of these things are aimed at the sort of realistic situation that people are not super clean in how they program. That like they are anticipating that there's going to be different things that weren't really designed to go together, and that they're just going to let you do the somewhat sloppy thing that you want to do, but not, the system's not going to crash because of it.
Yeah.
Like, is that like a fair way of stating one of the benefits of ROS?
Yeah.
I think so, yeah, that you end up crashing some component of ROS rather than the entire system.
And like me, I'm not much of a computer scientist. I'm not, I don't consider myself a great programmer. But they've got this team of all computer scientists writing ROS such that you can do what Todd just said. You can write crappy code. It's probably going to be okay.
Yeah.
I'd say that's fair.
So then I've sort of touched on this a little bit. The service is the other way you can communicate, which is just a one-to-one. And you ask for something and you wait until you get it back. And that requires its own set of message definitions. Okay, so got all this stuff flying around, messages and nodes and drivers and things. It can get a little bit unclear what ROS is actually doing in the background. So they give you this tool called RX Graph, which plots out your ROS world, like what's happening, what information is going where, and what nodes are currently running. So this is from a Lego NXT robot we just got off online. It's their system. And all these bubbles are nodes, and all the lines are communication. And on the far right there, you see all those lines going to something called ROS out. That's like standard out. If you send something to ROS out, you can see it on your screen, more or less. And then these are all the topic names. And then data is just being passed along that. And then if it was actually running, you could mouse over this and give you more information about the rate at which it was publishing stuff and other details. But it's a nice tool to figure out what you've actually created as opposed to what you think you've created.
So this is all running on your PC, and then ROS as is being sent to the next.
There is no connect here.
Yeah.
And then the next robot.
Oh, yeah.
It could be, yeah. So one of these nodes could be like an XP, and like an XP node, and then it would just be sending data to that, which would then grab the serial port and send data out on it. You probably wouldn't see, so it doesn't know anything past this XP node, but you'd see that.
In fact, we believe, we don't know exactly what's going on here, but that JS ag thing is probably a robot definition, how the NXT is currently configured. That might be a real robot, or it might just be a simulator. And that's something that's like really awesome about ROS. You can design all of this stuff, your extended Kalman filter, how you get IMU data, independently of whether you're actually running the system. So you can do all your debugging just in simulation, and you have two different nodes that you start, either the actual robot or just a simulation of the robot. And they just fit together in the same way.
Okay. Yeah. And some of their logging techniques really play to that functionality. I'll talk about that in a second. Now, actually. So now that you have all this data being passed around between these different nodes, you'd love a way to collect that data, and they give you that ability with something called bag files. I'm not sure why they call them bag files, but they do. And the nice thing about this tool is that it'll log whatever is being passed, because they've told you that you have to define the message structure ahead of time before you can use it, and then you have to pass it like that. It kind of knows how to collect that already, because it knows what your message definition is. So this message definition could contain joint states or point cloud data from the Connect or camera information, and you can log it all at once. And it just puts it in a compressed file they call bag file. And then maybe the most useful part of that is that once you've collected all this data, so you can see over there it's some data being collected from a PR2, and you have all the different camera streams, you can play that back. And ROS doesn't know the difference really between actual data coming in from the PR2, if you've done it properly, and a recorded set of data that you've played. So you can kind of recreate a situation that was happening, and if you want to change what filter you're using on that data, you can close that node and start a different filter node and replay a situation and see how it comes out this time. So that's kind of nice for debugging. Okay, so visualization, they talked a lot about RViz. There's a simpler tool called RxPlot, and that's you can intercept all those lines going from node to node. You can kind of get in the middle there, grab one of those message topics, take a parameter out of it, and just plot it live. Or you can log it. But if you want to watch things as they're developing, you can do that.
Is that Python?
This is
yeah, this is more. It's more of just command line. You just open RxPlot. You type RxPlot in command line, and it opens this. And then there's a GUI where you can say, I want to plot this message, and it'll start plotting it. And it auto does axes, and you have control over that. You can also, in Python or C++, you could write a node called my plotting node. And you could just start the plotting node, and it would just start plotting.
That was just in the comments. It looks like the matplotlib.
It does.
I was wondering if using it under.
I don't know what they wrote in.
Yeah, I have no clue. I think they do most of their development in C++. I actually have not seen anything that ROS has put out that was in Python. But they give you Python functionality for everything.
Okay, so then there's this next level of sophistication, RViz, which is really for viewing data with a spatial component. So it's like maps or connect data, so point cloud data. You can also do camera streams, transformations. Like when we are viewing the skeleton data we're collecting, we have coordinate frames on all the joints and their orientations, and it makes it it's a really good way to look at that. Over there you can see there's a solid model that they're viewing in RViz that then can be actuated with incoming data. But we'll see videos of this later that'll make it more clear. Okay, so the last thing I'm going to talk about is the community around ROS. And as I said, Willow Garage has kind of taken ownership of this software, and biannually or annually they release updates. They've only had 3 years to do it so far, but they're moving at a pretty good clip. And every time they do this, they kind of gather what has been an unstable or a beta type of package, and if it's good, they incorporate it into the main release. And now it's much easier to use, and they sort of make sure it runs smoothly and things like that. And I mentioned this before, repositories offered by other institutions that have adopted ROS. MIT's was huge for us in terms of understanding how to interface with the Connect and to move forward with our work. It was really nice to be able to just run that and see how it works. And then there's the wiki, which when you're learning is awesome because it's packed with tutorials, more than you could do. And might not be in all the subject areas you want, but there's a lot of them. And anybody can create a page and create their own documentation for any ROS software that they develop, which is nice.